Hello guys, welcome back to our channel. Today we are going to discuss about the different kind of interactions exist between molecules. First one is intramolecular interactions and the other one is intermolecular interactions. As you know, intra means within and inter is between. So intra means these kind of interactions exist within a molecule, and intermolecular interactions exist between molecules. And today we are going to discuss about the different kind of intermolecular interactions exist between molecules, and these are temporary interactions, not permanent interactions. And coming back to the A, that is the intramolecular interactions. These are actually can be permanent, like the sigma, pi bond and coordinate bond, but we will discuss those in the coming classes. Let's get started with the intermolecular interactions, which are temporary. So we have hydrogen bonding, we have dipole-dipole interactions and van der Waals interactions. Let's go one by one, starting from hydrogen bonds. So hydrogen bonding exists between a hydrogen and electronegative atom. So there should be one hydrogen and electronegative atom. Electronegative atom can be oxygen, nitrogen or fluorine or any other electronegative atoms, but hydrogen is compulsory. It should be hydrogen and some other electronegative atom. For example, we can look at the water molecule, for example H2O. In H2O, we have oxygen, we have hydrogen. So this hydrogen has partial positive charge and oxygen has partial negative charge. Because this oxygen is electronegative atom, so this will actually draw the bond pair of electrons towards the oxygen. So that's why the oxygen gets partial negative and hydrogen gets partial positive. Now we have a positive and negative poles within the water molecule. So this is one water molecule and we have another water molecule and we have another water molecule. So as you see, the pink color interactions exist between one oxygen of one water molecule and hydrogen of another water molecule. And same here, if you look at here, between hydrogen of this one and oxygen of the other molecule. So these are called hydrogen bonding or hydrogen bonding interaction. Hydrogen bonding is of two types. First one is intramolecular hydrogen bonding and intermolecular hydrogen bonding. So intramolecular means these hydrogen bonding happens within the molecule, within a molecule, like here. But intermolecular hydrogen bonding exists between two or more molecules. As you see here, this intramolecular hydrogen bonding is happening. The pink color interaction is intramolecular hydrogen bonding between hydrogen and oxygen of same molecule. But if you look at the intermolecular hydrogen bonding, here oxygen of one molecule and hydrogen of the other molecule, as usually the pink color interaction is hydrogen bonding. Intramolecular hydrogen bonding exists in ortho-nitrophenol and intermolecular hydrogen bonding exists in water molecule and also para-nitrophenol. So second one is dipole-dipole interactions. So dipole-dipole interaction exists between two permanent dipoles. In the case of hydrogen chloride, HCl, so hydrogen has partial positive and chlorine has partial negative. This is permanent dipole. And the dipole-dipole interaction is happening between chlorine of one HCl molecule and hydrogen of the other HCl molecule. So dipole-dipole interaction happens between two atoms of electronegative difference. There should be electronegative difference between the two atoms. In the case of hydrogen and chlorine, there is electronegative difference, like more electronegative difference. It can be hydrogen chlorine or it cannot be. Maybe as in the case of hydrogen bonding, one atom should be hydrogen, but in the case of dipole-dipole interaction, the two atoms may not be hydrogen. Like one may be chlorine, the other may be some other atom. And coming back to the van der Waals interactions, so these happen between non-polar molecules. So van der Waals interaction happens between temporary dipoles. So as you see, we have hexane molecule. So this is one hexane molecule and we have another hexane molecule, the second one. So the van der Waals interactions are happening between these two molecules. So these hexane molecule will form some temporary dipoles, like one side positive charge, the other side is negative charge, because sometimes the electron cloud may shift more toward the one side than the other. If the electron cloud is moving more to the one side, it gets negative charge and the other side gets partial positive charge. So these are temporary dipoles. They may change time to time. Like in this case, we have a positive charge. The van der Waals interactions are happening, the blue color dots you can see. So these are happening between two hexane molecules, like positive and negative. But this is like a dipole, but this is a temporary dipole. These will change. And van der Waal interactions increases with the surface area. So we have another example. So this example we have ethane. Actually, ethane is a gas. Okay, but for example, just imagine the van der Waal interactions happening between two ethane molecules is less compared to the van der Waal interactions happening between two hexane molecules, because in hexane there is a more surface area than ethane. So if there is a more surface area, van der Waal interaction is more. Okay, so before we sum up, just let's review. So hydrogen bonding exists between a hydrogen and electronegative atom, and then dipole-dipole interaction exists between two permanent dipoles, and van der Waal interactions happen between two temporary dipoles. So that one example for hydrogen bonding is water, and for dipole-dipole interaction is HCl, and for van der Waal interaction is hexane or petrol or gasoline. So let's do one of the applications. Why we need to learn these temporary interactions? As we know, boiling point is directly proportional to strength of interaction. In the case of water molecule, just write H2O, H2O and H2O, right? Because this happens between oxygen and hydrogen, and we have H2S and so H2S. So we have hydrogen bonding exists between oxygen and hydrogen, and also sulfur and hydrogen. Because sulfur and hydrogen is electropositive and sulfur is electronegative, but less electronegative than oxygen. So here the hydrogen bonding is happening between oxygen and hydrogen. Let's just write interaction, and in here we have sulfur and hydrogen. So between oxygen and sulfur, oxygen is more electronegative than sulfur. That's why the interaction is strong. The hydrogen bonding interaction is strong in the case of oxygen and hydrogen than sulfur and hydrogen. So in water molecules, strong hydrogen bonding exists. That's why more boiling point. The boiling point is 100 degrees centigrade. But in the case of H2Ls, is a weak hydrogen bonding, because the hydrogen bonding strength is not that much great. So that's why the boiling point is minus 60 centigrade. And coming to the hexane and butane. So in hexane, we have more surface area. As I explained before, hexane has 6 carbon atoms, right? So we have 6 carbon atoms, 3 and 3, and in the case of butane, it has only 4 carbon atoms. So this is butane. So we have butane 4 carbon atoms and hexane 6 carbon atoms. So here in the case of hexane, more surface area. So here we have more surface area, and here less surface area compared to hexane. Like relatively, like hexane has more surface area than butane. That's why hexane has a more boiling point than butane. Butane has less boiling point because the surface area is less and the van der Waal interactions are less in butane. So here more van der Waal interactions, and here is actually less van der Waal interactions. Okay guys, thank you very much for watching the video. Please like, comment and share this video, and I will come up with more interesting chemistry topics in the coming classes.